to the first grade Math Dive in 5 for addition and subtraction problem solving. I'm Rebecca Ore, and I'm the Math DRT.
I'm Jack Faley, and I am the K-5 Math Supervisor.
So first, we want you guys to pause the video and read through these tasks and solve them as if you were a student. Think about what strategies and tools you want students to use and that you might use as you're solving them. Welcome back. Now let's take a look at the progression with the best standards. Here's what students were doing in kindergarten last year, and here's what students will be doing in first grade. What are some things that you notice?
I see right away the numbers jumped for them from kindergarten to first grade. Now they're working up to 20.
Yep, they're working up to 20, and they have been working up to 20 so far this year, so they have some experience.
So really we're just talking about making it in those problem-solving situations and helping them figure out those problem-solving situations?
Yep, exactly. And then how is what we're doing now going to help them for future grade levels?
Oh, they're going to be using this for a long time, like their whole life.
For sure.
But I see in second grade they're going to jump to two-step problems. That'll be a big.
Yes, so we want to make sure that they're really solid with these one-step problems so that they're more successful in future grade levels. Okay, so when you solve these problems, what were some of the tools and strategies that you used?
Right away when I was looking, I was thinking about making a 10 was a strategy I might use. Counting up is always, I like using that one. I use it in my life all the time. So those are a couple that I was thinking of.
Here are some other examples that you may have thought of too, or some other people who did these tasks. There's definitely different strategies, and a lot of those you've already taught students. So we want them to use those strategies as they're solving these problems. But also think about, like, how did you feel when you did these problems? Did you feel like they were easy? You read them once, solved them, and you were done?
I mean, the numbers obviously weren't hard for me because I'm the supervisor. No, but the challenge was really just making sure I understood what the problem was asking. So it's that problem solving that I had to read them a couple times.
Yeah, especially because these are not just like take some, add some more, and then there's your answer. You really had to make sense. So we want to keep those things in mind when we're thinking of our students. We want to remember that they might also have anxieties or struggle when it comes to these problems. These are the 3 different types of problems that you are presented with. Compare, difference unknown, put together, add and unknown, take from, change unknown, and maybe these are like, what are you talking about, right? So hopefully you have seen this, and I know it was in a previous Math Dive in 5 this year. These are all the different problem types that students should be exposed to. The unshaded problem types are expectations for kindergarten. These are typically our go-to when we have to create our own, especially the add to and take from. Like there are some frogs on a log, some more jump on, how many are there left?
But I like those the best.
They're definitely easier for us and for students, right? But to help our students be successful, we want to expose them to all the different problem types in first grade. The darker shading indicates the most difficult types that students should work with in first grade, but not need to master until second grade.
Oh, that is a really great chart. I think that's excellent to just kind of keep as you're lesson planning and as you're going through this to make sure that you're hitting all of those types. Where would I find this chart, Rebecca?
So this is going to be within the standards documents. It's in Appendix A if you want to go find it.
Awesome.
All right, so we want to make sure that students are making sense of problems. I'm sure you've given problems to students before, and what's the first thing that they do?
They just add the numbers.
Do they read?
No.
They pick them out. Exactly. They pick them out, and of course, who doesn't like adding? They add them together. So instead of doing that, we want to make habits and routines that students aren't becoming number pickers. One way we can do that is by, again, doing a routine, something like starting with every single time we read a word problem, we want to read it aloud twice, at least twice. We don't want to ask them any questions. We just want to read it out loud so that they can picture what's going on. Then once they picture it, then we start to make sense. So we're still not solving anything yet. Then they can go ahead and solve and then reread the problem to make sure it makes sense. Now, maybe you're thinking, well, what do you mean making sense of the problem? What does that look like? So thinking about this problem, I might read it twice to you. Then I would ask some questions like, what is this problem about? What would you say this problem's about?
It looks like it's about pens.
Pens. That's plenty. I know that you read the problem and you have an understanding what it's about. So if they are like rereading the problem or they're trying to come up with a bunch of things, you might want to even just say, what's one word? Pens. Then we could say, well, what do we know about the pens?
Oh, did you want to know?
Sure.
Okay. They're different colors, and I know that some of them are blue, but we're also trying to figure out how many are green.
That's exactly right. And you just answer the next question. If students don't get there, we could say, what are we trying to figure out? And then what tools will you use to solve? So we might start brainstorming some tools we can use to model the pens that are blue and that are green. Keep in mind, he didn't write an equation yet. We didn't pick out any tools yet. We're just talking about how we're going to go about solving this problem.
I haven't even added 19 and 11 yet.
You have not. I made sure you haven't added 19 and 11 yet. So we want to make sure that we slow down, read, and start making sense of the problems. So once students start making sense of problems, then they're ready to solve. Here's an example of a part-part whole mat that you might introduce to students to solve a problem like this. You ask them some questions and have them model the total number of pens. Then they can model the number of pens that are blue and then move the model to show the number of pens that are green. Then they also can start, as you can see, putting the numbers on the part-part whole mat, which eventually get them to writing equations and making sense that way. Another example would be for students to draw. Let's say they're ready to move on from concrete tools and now they're drawing what it means, what the problem means. So they have their pens, then they might use some colored markers or pencils to show what are blue, to show which ones are green, and then asking, does it make sense? And then putting numbers and labels to their model so that when you're asking them, does it make sense, you're continuing to relate back to that context of the problem.
I like that.
So when we solved this problem initially, if we're not thinking from a first grader perspective, we might think this is actually a subtraction problem, right? Because it's like the leftover, we don't know what it is. Notice that the student wrote an addition problem. So to help them see the connection, we want them to look at both problems and ask them, how are the equations similar? Because it is also an expectation of first grade that they're making connections between those equations. One misconception which you've probably experienced is that students draw a bunch of things or build a bunch of things and then they can't count it or they count it multiple ways. So to help with this, we want them to use organizational tools such as part-part whole mats or part-part whole, what is that called? Diagram and tens frames. Another misconception is that students have difficulty with problems such as the ones that I showed you previously. So what we want to do for that is to continue to have them build concrete models and talk about information and making sense of the problems. And lastly, the common misconception is that students, like we said at the very beginning of this video, they just start adding things together, or maybe they're looking for keywords or listening for keywords. We do not want to focus on keywords that go with addition and subtraction problems. Instead, make a nice poster that looks like this about how do we make sense. So every single time we read a problem, instead of looking at keywords, we're asking the same questions to make sense of the problem first.
That would make an awesome anchor chart in a classroom.
For sure. Remember that students will most likely not master all problem types with abstract thinking by the end of this unit, but when do we want them to get there?
By the end of the school year.
By the end of the school year, by the end of first grade. So keep in mind to provide concrete representational abstract thinking models for your students. And that's all for this Math Dive in 5. We'll see you next time.